I understand correctly. Right. If that's the case, then you want to say how to connect your work with the underlying system part. It may not be very as strong connection as group one, but there should be something there.
Okay, sure.
Okay, good. Group four. Anyone here? Group four, if not, okay, group five.
Okay. The project of our proposal is rely on the LiDAR points, color data, and the complex UHO V4 algorithm to detect the object in the self-driving. The technique will be used for the self-driving in the three-dimensional 3D, so there will be bring the more practice detection. For the LiDAR, we rely on the LiDAR because it has a lot of advantages, such as it could provide a great projection under the complex weather condition or other complex conditions. The basic strategy of an appliance is we rely on the complex YOLO network models to replace the image and process those data for the model and select the label and adjust data. Next step is the converting the image to the model accept the text. For the expectation and the deliverable is from the data LiDAR points, the model is trained by the complex YOLO V4 and produced some visual image for the model production result. We used the algorithm I have mentioned to see how fast it is and compared under the three-dimensional detection, and compare the result in the normal algorithm with the transforming from the 3D and 2D. The detection will the compare include other phases, the speed detection and algorithm. The compare also in our project proposal. Okay, I think that's all.
Okay, so again, will you repeat your deliverables?
Okay.
So what
okay, I will repeat. We will use the complex YOLO algorithm. That's a new algorithm to see how fast it can be for the 3D detection, and compare the result with the normal algorithm, which transforming 3D data to 2D data. And we will analyze the difference between the speed of the detection and accuracy from the old algorithm to new algorithm.
Okay, so the algorithm is already developed in the literature, right? So
yes.
you're just evaluating that one.
Yes.
Okay, so again, for this one, how is this related to the big data systems? It's an evaluation of an existing algorithm.
I think I think yes.
Right, so the detect objects for self-driving, of course, involved a lot of systems, right?
Yeah.
But the project you propose per se does not involve any of them.
We just be a part of the detection for the self-driving, and we can use this algorithm to help the self-driving to detect the
For example,
yeah.
the speed of the detection, right? I think it's heavily depend on what system you use, right?
Yeah.
So therefore, if you use a different one from the practice, then it will be fairly different.
Yeah, that's always in my project to analyze what's different and what's the advantage and what's the disadvantage for the new algorithm.
Not only algorithm, but I mean the platform which you run the algorithm matters probably more, right?
Okay.
If I just
Yeah.
give you a very low end or even low end server or even Raspberry Pi, probably you cannot even run it. But if I give you a very powerful server, then you can probably run it very fast.
Okay.
The and your result will heavily depend on your platform.
Yes, I think we should think about a lot of we should think more from your mention.
Yes,
Yeah.
I think for this course consideration, you want to, in addition to what you propose here, you probably want to evaluate that algorithm on different platforms. For example, you may have some servers yourself or a laptop or desktop, or you can try it on a more powerful server in Cloud Lab, right? So
Huh.
try to see the difference there. Right? So from there, probably there is something you can connect your project with the system part.
Okay.
Okay, that's good. Next group. Is apparently anyone from group 4 here? No, group 6.
Yeah, hi, Professor. Let me share my screen here. Ooh, okay, yeah. Could you see my screen here?
Yes, I can.
Okay, yeah. So we're group 6, and so of our project, like we're gonna study the IPFS, which is the distributed storage network, and we're mainly targeting of the application of video streaming. Yeah. So we basically we're gonna study the how this decentralized network actually benefits in the video streaming scenario. So we found this application called D2. Which is operates on the IPFS. So it's basically like a decentralized video platform, and it operates like a YouTube channel. So but it's operate on the decentralized backbone, so you can actually get rewards based on your uploaded videos, and also you get more rewards if your video becomes the trending videos. Yeah. So our goal is actually that we're trying to know that if these decentralized network actually helps in the video streaming scenario. So we know that distributed networks is better because we don't have censorship, we don't have centralized control. But we have to know that if it's actually beneficial and if the video quality is good enough for us to actually use it. Yeah. So our methodology is that we're trying to retrieve the videos content identifier. You can think of it as the videos ID, and then try to inspect the network packets and to see if to see the bandwidth, etc., how it works. Yeah. So for the evaluation, I'll give it to my team member Yu Hao. Yeah.
Okay. Hello everyone, and our group will evaluate the left circle of the video in D2. We have record with the following 4 methods. The first one we want to focus on is how long will the video expire in the IPF network. And the second one is we just focus on the bandwidth for downloading this video, and that they are vary. And the third one is the video will be served by different peer, because they mentioned they will be decentralized and there will be many nodes from the different peer. And the last one, we just want focused on how fast can we retrieve the video, and they affect by the geolocations. There has been similar one, but they're only focused on the what a connective for DTube video compared to YouTube. But in our project, we also will focus on a lot of other things, like we will try to understand if the DTube if the DTube is really did something about decentralized, like the fourth method we mentioned before. And we will also, after that, we will get a lot of data, we think, and we will do like things about data visualization, and we will see how the things going on about the IPFS and the DTube, and we will know.
Yeah, I need to stop you because you already go over time. But
oh, okay. Sorry.
Okay, so this is a perfect time to stop because you show the timeline here.
Yes.
Yeah, your plan sounds great. So that's the best I see so far. So every other groups, this is a good example, right? It touch the system component, the deliverable very clear, and the timeline already there. Right. So this is what I really want to say. Yeah, good work.
Okay, thank you, Professor.
Thank you, Professor.
Group 7.
Hi, Professor.
Yeah, please go ahead.
So basically, we're gonna do we're gonna propose about the algorithm for missing data, which is mice and size. So as you may know that the mice algorithm has tackled the data, the missing data with a prediction from underlying linear regression model. But like and after that, but like there's gonna take a very big number of time for the prediction value to convert to a specific value. So after that, the site algorithm have improved on that based on like just run the mice algorithm for just an n number of time, and it's like less than 100. And after that, the site algorithm is gonna take like the median, the mode, or the mean return of those prediction value for the missing data. So so these technique, has the drawback, and also have some doubtful. So we're gonna like so how can we like improve those algorithm? As you may see, the mice algorithm use the underlying linear regression model. So basically, we want to propose two main modification. First, the underlying algorithm for mice will be expanded to other more sophisticated algorithms such as deep learning for continuous data, or support vector machine or random forest for binary data. And after that, we also like want to improve the accuracy of the prediction by improve the quality of the feature, which is do some feature engineering techniques to improve the data standard. Yeah. And the final deliverable is that we want to to make the result more accurate, and then to make the result more clean. And the first part of our deliverable would be include a Python library consisting of function that that the user can modify the underlying algorithm and how many times the user want the algorithm to run. And after that, and the second half of the deliverable would be like the analysis of the performance of the traditional mice and site algorithm, and compared to our proposed modified size and mice algorithm. And the focus of this analysis is to compare the accuracy of the imputation between those methods. So the timeline and the timeline is that like we will have a meeting, weekly meeting, and having the first graph of the library, Python library, complete by November 6th. And 2 weeks after this, we're gonna have the final version of the Python library, and then like we gonna do the final report in the last week and then submit. I'm sorry, you may mute your micro.
Oh, sorry. So I mean, this is the algorithm for